Welcome to today's presentation. Today we're going to do a practical demonstration of a leading competitor 3-fluted drill bit which has a sharp leading flute edge and a 3-fluted single bit which has a radius flute edge. What I have here in front of me is a piece of nylon string, this pink nylon string, which simulates a ligament, a tendon or a piece of soft tissue that we would find in the body. I'm going to take the 3-fluted radius leading edge single bit and load it into the power device, and I'm going to spin it against this piece of string. And you can see here that this string is tensioned quite tight. So as I spin the single bit against this piece of string, you can see that it causes no damage whatsoever, and that simulates what that would do inside the body. When I take the leading competitor 3-fluted sharp leading edge drill bit and spin it, you'll see that it does something quite different. It cuts through that very, very quickly, and that would simulate what that device would do inside the body. Another important aspect of drilling in orthopaedic surgery is the drilling of bone at angles, and I'm going to simulate that today by drilling through this piece of polyethylene tubing. I'm going to take a leading competitor 3-fluted drill bit and load it into the power device, and I'm going to drill this piece of polyethylene at an angle. And you can see that I've gone through there, but if I apply any sideward force on the power device, you can see that it will continue to side cut. And you can see quite clearly there that you've compromised the whole geometry. I'm going to remove the leading competitor 3-fluted drill bit on the market and replace it with the single bit and perform the same task. So placing the drill at an angle, activating the power device, putting straight through, you can actually see that it actually drilled a lot faster. But if I then apply sideward force, which I'm actually pulling quite hard on the drill bit right now, you can see that it's not compromising the whole geometry. And that's an important factor when having to place a screw into those holes. One has a compromised hole geometry and one has a perfectly symmetrical hole geometry. And the difference is that the thread fixation in the symmetrical hole geometry would be a lot better than the one with the compromised hole geometry. Another aspect of orthopaedic surgery that requires the drilling of holes for the insertion of fixation devices is external fixation pins, or for external fixation systems. They are either done with pre-drilling a hole and then using a ball tip pin. The reason the tip is ball tip is to preserve tissues beyond the far cortex. There is also a self-centering, self-drilling, self-tapping device, and the drills are normally drilled first, and then they're normally finished off with a hand device. But I'm going to load a single bit, which is a Singular Orthopaedics drill bit product, and I'm going to drill a hole at an angle. And then I'm going to remove the drill and place a ball tip Singular Orthopaedics external fixation pin, and I'm going to slow the drill down to a lower speed, and you can see that I'm going to start this hole. I've hit the far cortex. I'm going to remove the drill device, and then I'm going to finish it off by hand, and this will allow me to use the image intensifier to see when that pin is actually protruding beyond the far cortex. So it allows the surgeon maximum control of the device. The other product that I have is the self-centering, self-drilling, self-tapping device, and I can load that into the power unit. I can slow that down to a lower speed, and again I can approach the bone, or the simulated bone, which is this piece of polyethylene, at an angle, and I can drill. I've started the thread engagement. I can then remove the power device and attach the hand device, and I can just wind that in, and then it hits the far cortex, and I can feel that cutting through, and now that is protruding just perfectly. So again, two other revolutionary type products from Singular Orthopaedics to provide surgeons with the best of surgical applications. So thank you for joining us for today's presentation and watching the advantages of Singular's technologies, the non-side cutting capabilities, the soft tissue friendly capabilities, the self-centering, self-drilling, self-tapping pins. These products are all available now from Singular's licensed OEM manufacturers around the world. Once again, it's been a pleasure having hosted this presentation, and we look forward to servicing your needs. Thanks for watching.